Hi, welcome back. Good to see you again. What are we going to do here? Well, we're looking at further coordinate geometry, this time with distances and midpoints. Distances between lines, between points, and the midpoint of line. Let's have a look at the grid here and see what the problem might be that we're going to try and solve here. Coordinates of point A are, what have we got? 1, 2, 3, 4. 4 in the X and 1, 2 in the Y. Remember that, the X number comes first, the Y number second. And then our point B would be 0. We've travelled no distance away from that Y-axis in the X direction, so 0 and 2. And then over here with C, we've gone -3 and up 1, so it's -3, 1. And D is -1, 0. Do you remember all of this? E is 1 and -2. Let's just check that. Come across 1 and down -2. Now our problem is to say, well, okay, if we're going from B to A, I guess not a real hard job to work out the distance. They've got the same Y value, so it's just a difference in the X's. It's 4 units. Hey, it's a bit more problematic if we wanted to go there from A to E. How long is that? It's at an angle to the axes. You can't just add up squares. Well, I suppose you could try to go across the diagonals. Oh, but how far is that? Across the diagonal of the squares. Oh, might have used Pythagoras or something there. So can you see our problem? When they are horizontal or vertical lines, not too bad. We can find midpoints as well quite easily there. But when the lines are angled, we're going to have to do some work to work out the distance and also the midpoint. So let's get busy. Come down here with me and let's have a look at what we've got here. This is from Hayes and Harris textbook for Year 10. And we're going to consider the points A, 1, 3 and B, 4, 1. So let's plot them first of all. 1 in the X and up here 3 in the Y. So we're going up 3. So there's the point A, 1, 3. And the point here B is out at 4 and up 1. Got it? Remember that. X number first. Don't forget that. That's going to be crucial throughout all our work. Y number is second. Okay. So here we go. Now, if we, as I mentioned before, we're travelling diagonally, so maybe we make a little right-angle triangle here and say, well, in the Y direction we went up 3 from a position of 1, so that Y movement up there is 2, and in the X movement we went from 1 to 4, so that's a movement of 3. So we have a little right-angle triangle. Lots of right-angle triangles in the Cartesian plane because our X values and our Y values are measured horizontally and vertically. So there's always going to be a 90 there. See that one there? And so in this triangle we have Pythagoras operating. The square on a hypotenuse, come over here. The square on the hypotenuse is the sum of the squares on the other two sides. So we have d squared equals 13, or d is root 13. You should put d greater than 0 because there are actually, remember, two solutions to the expression or equation d squared equals 13. D is plus or minus root 13 because positive root 13 by positive root 13 gives 13, and neg root 13 by neg root 13, also negative times a negative is a positive. We're going to discard that one because we're talking about a distance here, and distances and lengths must be positive. So we've just been able to find the length of that line or the distance between 2 points. Alright, let's go and do some together now. Here's the first little exercise, and we'll do the same sort of thing here. I'll do some with you and then leave you to do the rest. Here are the answers down here. So let's have a look at the length of AB. That's just a vertical line. We'll count the squares. It's 2 units. Okay, if we wanted to do part B over here between A and D, is that an angled line? Yes, it is. There it is down there. So we've got a long skinny triangle. Let's just draw that in, we can break it into an x movement. How many squares are there here? 1, 2, 3, 4, 5, 6. That's 6. And across here we've got a movement of 1. So doing Pythagoras, the distance squared is the sum of the squares, the other two sides, hypotenuse squared, remember, all that stuff. And so d squared is 36 plus 1, d squared is 37, so d is just a positive root of 37 because it's got to be greater than 0. You really should put this in because you're saying that basically there are two solutions, but I'm only choosing one of them. Alright, so you might pause the presentation now and check out the other ones. We've done a couple together. You're up to part C now. When you get the hang of it, you can just move on. Alright, so I'm going to move on now, and let's have a look at making a formula. We don't generally want to do a diagram every time. So can we find here, to avoid drawing a diagram, can we have a system or a formula? Well, let's have a look. If we have one point, call it x1, y1, hey, we've done this before, and the other one x2, y2, with slopes and equations and stuff. And you could go in either order, it doesn't matter which one you call x1, y1, which one you call x2, y2. Let's have a look at trying to work out what we've just done. We worked out the vertical movement by getting the second y and minus the first. So this will be y2, take y1. Just seeing how far up in the y direction we've travelled. And in the x direction, same as with the slope idea. It's the same diagram, same geometry. It's the second x minus the first. And so if we wanted to make a formula, what would we tell people? We'd say that length d here, ab squared if you like, is the x step squared plus the y step squared by Pythagoras. Okay, same stuff. That's what we've just been doing. And so here we have a formula. It's the same calculation here of the y step and the x step. I just put that back. Same calculation for y step and x step as we used in the slope or gradient. So now we have a formula that you could just plug the values into to actually do it, find the distance, without actually plotting the points. Okay, let's come down and have a look at an example. Okay, so here we are. Example here, distance between -2, 1 and 3, 4. So you can do this over here. I wouldn't, they're just trying to explain what you're doing. I wouldn't necessarily put those down. I think I would try to mathematically explain what I'm doing by putting down the formula. I think that's good to put. Here we go. Let's just tidy this up a bit. So I'd put the formula. Stop laughing. So here, x2 take x1 squared plus y2 take y1 squared. So that's the x step squared, the y step squared, and using Pythagoras, of course. So I think I would do that and then start doing your working as I have here. So second x minus the first. Look out, look out. We're subtracting a negative. What's that? And a negative times a negative is a positive, so it's going to come to 5. But just watch that subtraction. Then it's 4 take 1. And don't cross over. Keep the x's together. A lot of people get confused and put 4 take neg 2. Right? It's these two together, the y's together, and the x's together. Don't cross over. And so this is 4 take 1, which is 3 squared, and it works out to root 34 units. And here's the point down here. With an actual formula, we don't actually have to plot the points, which sometimes can get very messy, having to plot the points all the time. So let's do some. So watch that example there. We'll just put him up there. So I want you to start with writing down the formula, which comes from Pythagoras, and then going through these problems here in 7A2 from Hayes and Harris. And you might just do the left-hand column perhaps, but it's good to get practice. If you're playing a sport, what do you do? If you want to shoot baskets or playing soccer, score, then you spend hours in front of those goals. So do you want to score here? Well, let's spend some time. Okay, and there are the answers down the bottom here. So pause the presentation now and get on top of that little bit. All right, I'm going to go on now. Let's have a look down at another possible use for the distance formula. I'll just bring all that up now. So here, what about working out whether a triangle is equilateral or isosceles or neither of those? What about something like this here? So where we have 3 points, of course, A, B and C, there are 3 possible sides. Let's just draw that up. A, B and C. So we would look at AB, BC and AC. They're the 3 possible combos to get sides of a triangle. So let's use that formula. There it is there for AB. Square root of, let's just check it. x2 take x1, 2 take neg2, all squared, there it is. And 1 take naught, all squared. So that's for AB done. Let's do BC. BC is over here, so 1 take 2. There it is, all squared, plus neg 3 take 1, all squared. And then when we do this, be careful, 1 take 2 is neg 1, neg 3 take 1 is neg 4, and when we square it, it's going to be 1 plus 16, or root 17. Now we can do the same thing with AC, and we'll get root 18, and we've got root 17 and root 17. So we've only got 2 sides equal, AB and BC. So the triangle is isosceles. Now to help you with this one, you might have plotted it, but you don't have to. So we can now draw this as AB equals BC. Well, let's have a look here. What could we do? It would look like this, isn't it? AB, or I've made it look almost equilateral. AB equals BC. Those 2 are equal, is what we've just found. Now you could actually plot them on a grid to have a look first, but it's not necessary now. With our distance formula, we can pop right in there and find the actual length. So not a bad idea to write that down every time you're going to use it in a problem. It gives mathematical justification to your working as well. Okay, so here's some problems for you. Have a go, and you might try 3 or 4 or all of them. And here are the answers down here. Don't have a look too quickly. Have a go yourself. All right, pause it and have a go. I'm going to go on now. What else can we do? Let's bring this up now. What else can we do? Oh, could we show that a triangle is right-angled using distances? I think so. Because if a triangle is right-angled, there's a special relationship, isn't it? You know, Pythagoras said the square on the hypotenuse equals the sum of the squares of the other 2 sides. So if we can find all 3 sides and look for that combo, is 1 squared equals the sum of the other 2 squared? Let's do it. Let's try AB. So remember, if you get 3 points, then the 3 combinations of sides, AB, AC, and then BC, they will give you the 3 sides of the triangle. So each one in combo. So let's do AB. AB 2 take 1 squared. There it is. 5 take 2 squared. Don't cross over. X's together, Y's together. So this is 1 squared and 5 take 2, 3 squared. That's root 10. Let's try BC now. BC are these 2 dudes here. So 4 take 2, all squared. 1 take 5. Getting the hang of this? So 2 squared and neg 4 squared. Of course, when you square, it's going to be a positive here. It doesn't matter which way around you put this because you're going to square it. It doesn't matter which one you call y1, y2. After squaring, they'll both be positive. So it's root 20. Let's go to AC now. We've got to do it with AC. 4 take 1 squared and 1 take 2 squared. Getting messy up there, so I didn't do it with arrows this time. So there we have root 10. Now what have we got? Well, we've got actually an isosceles triangle, but what we're trying to do is see if it's right angled. We've got 2 sides equal, and there's the third one there. Now let's have a look. When we square AB and square AC, that's that one and that one, we've got 10 plus 10. Root 10 squared is just 10. So that comes to 20, and B squared is 20. Therefore we have done it. Now I would like to have a different line in here. I would like to say that is AB squared plus AC squared equals BC squared. Therefore triangle ABC is right angled, just the same as that, a little bit of difference, right angled at A, and put here by Pythagoras. Okay, so they've left out the formal statement. They've got the 2 lines showing them equal, but I would make this formal statement showing the sum of 2 sides squared equals the square on the third side. And then they've drawn a picture, of course. And the side opposite the 90 is the biggest angle, so that must be the biggest side. And we just got a picture of what's going on there. So I think you should do all 4 of these down below here. And it's saying where the right angle is. So you'll need to draw a triangle, I think, and label the sides, get a picture of what's going on there. Okay, you don't have to draw it on the grid like these guys here haven't drawn it on the grid, or you could draw it on the grid and just inspect. Okay, have a go, and I'll catch you down below here. Alright, here we go. Here's a puzzle problem for you, where we are told there's this point, but there's a mystery point, B1. We know its Y value, but we don't know its X value. Where would it be if these 2 points are 13 units apart? Well, this dude here says there are 2 possible solutions. Example, draw a diagram, see why this is so. Well, let's do that. If we've got a point, let's say A, which is 3, neg 2, and B, now maybe we'll plot it properly. Let's do it properly here. So here's the X, positive axis. Okay, so here we go. 1, 2, 3, neg 2. This is A is 3, neg 2. All we know about B is its Y value is 1. What does that mean? It lies somewhere along there where all the Y's are 1. Now, can you see, to get another point, root 13 away, it could be sort of either there or there, couldn't it? Where these would be root 13s. So B has to lie on this line because the Y is 1, and we're told that. But it could lie in 2 different positions there on that line. So we sort of can see that. Let's go and try and do the distance formula now. And the distance formula between these 2 points would be the square root of B take 3 squared. Remember, you're pretty accomplished in algebra now, and so B shouldn't worry you. B's just another number. So when you're using the formula, and here it is again, putting down the formula, x2 take x1 squared plus y2 take y1 squared. When you're doing that, sure, why can't B take the place of x2 there? Why shouldn't it? B is standing for a number in algebra land. So then let's do this one here, 1 take neg 2. And they haven't put the full steps in there. Oh yes, there it is. 1 take neg 2. Negative times a negative is a positive, so I get positive 3. So we get root 13 there, because we're told they've got to be root 13 units apart. So now squaring both sides, we get this little creature here, B take 3 squared plus 9 equals 13. Subtracting 9 from both sides, B take 3 all squared is 4. Let's take the square root of both sides. Remember, we're trying to get back to the unknown, unpacking your present, unpacking the operations done to that unknown. And that will give us, don't forget, the 2 solutions now. right? There are two numbers which multiply together to give 4. A positive 2 by positive 2 gives 4. Neg 2 by neg 2 gives positive 4 also. So now solving that, I would prefer it written out like this. B take 3 equals 2, or B take 3 equals neg 2. Therefore B equals 5, or this one implies B equals neg 2 plus 3, which is 1. So we've got two answers. B is 5 or 1. So that agrees here, doesn't it? We could have 5, 1 or 1, 1, just like I've drawn it there. So both of those would be root 13 units away from A. Nice little puzzle problem. So have a go here and see what you think. Why don't you try to actually draw up a grid and see what's happening? Because we are doing geometry, you know. Coordinate geometry is putting geometric shapes on the Cartesian plane and playing around with coordinates to look at lengths and later on parallelism and things like that. Okay, so have a go. Now we're going to leave this now and we're going to go on to midpoints. So come down here with me and let's have a look at the midpoints idea. So here we have a grid again, and the aim this time is if the line is angled, that is, it's not vertical or horizontal, because they are the easier ones. You just count up squares there, as for distances. But if the line is not vertical or horizontal, how do you get its middle point? Because it's often on this angle here, angled off. How do you get into the middle of that line? It's not as if we're just going like this. The middle of that line is obviously that point there. When it's angled, it's harder to work out. You're going across squares. You can't work out how far that is. Okay, well, with our diagram here, this one's turned out nice and easily because you can see it's landed in there, and that is the midpoint. That's what we want. Halfway between A and B in X-land. So what's halfway between 2 points? Oh, that's the average. Okay, so if we're looking at 1, 2 and 5, 4 as we are here, then halfway between them in the X value would be the mean or the average. 5 plus 1 on 2, or 3 is the answer to that. And then what is the halfway movement in the Y, just looking there? That Y value there would be the mean or the average of these two. 4 plus 2 on 6. Later on, doing something called similar triangles and enlargement, you can actually prove that that's the case. It's you're not quite ready mathematically to do that yet, probably. So, can we have a formula? We don't want to have to draw graphs all the time, so let's have a look at the formula down here. What are we doing? To find the middle point, we average the x's, that is, add them up and divide by 2, and do the same with the y's, so that you can get that middle point. Okay, you don't need to draw a diagram. The idea is to use the formula now. So let's go and practice. So here's an example now, and there's some problems for you. Find the coordinates of the midpoint, middle way between these two. You might say, well, hang on. Huddy, you said we were doing geometry. Why would I want midpoints? Oh, let's just have a look. In geometry, I don't know whether you've had this theorem yet, but in geometry, if you have a triangle and you join the midpoints, oh, there it is, midpoints, join the midpoints of two sides like that, then this side here is parallel to this other side and half its length. So in coordinate geometry land on the Cartesian plane, we could now prove that, couldn't we? We know how to find parallel lines that have the same slope, and now we actually can find these midpoints. So we could prove that with coordinate geometry. So that's the idea, being able to do anything geometrically that we want on the Cartesian plane. Okay, so here's our here are our 2 points. I rather like putting down the formula for each one, like that. Okay, halfway at the average of the two. But anyway, here we go, putting the numbers in. -1 plus 4, there it is on 2. And 3 plus 7 on 2. Using the idea that the midpoint of a line is the average of the x's and the average of the y's. So there's our midpoint. Do you think you can do it? Now the idea, of course, is you can check with plotting, but the idea is to just use the formula to quickly ascertain what the midpoint is. And here's your solutions here. So have some practice there. Watch out particularly for the negatives, right? And up here, the negatives there. Watch out that you get those correct. That all work with directed numbers. Okay, pause the presentation, have a go. I'm going on now. They're coming down. What else can we do with midpoints? Oh well, we could say, well, if we have a midpoint given to us and a point on the end of the line, how do you find the other end? Well, that's a bit of a tricky do here. There's an end and we know the midpoint. Get the difference? We know the midpoint and we don't know what that point is. A little drawing there. So if you're trying to find this point, what can you say? Well, don't be frightened of letters. In algebra land, they help you solve lots of problems like this one now. If the midpoint here, to get its x, what do? It's the average of the x's on the ends. A plus 1 on 2 has got to come to 4. And this one here, b plus 3 on 2, the average of the y's, must come to the y value of the midpoint, -2. So we're going to backtrack. We're going to backtrack from knowing the midpoint back to one of the ends. And here we go. If you do this now, multiplying both sides by 2, a plus 1 equals 8, subtract 1, you get 7. And over here, multiplying both sides by 2, b plus 3 equals -4, subtract 3, and you get -7. So we've actually backtracked from the midpoint down to one of the ends. Same idea though, big M for midpoint, not little m, that's the slope, remember, slope or gradient. But here's what we're using every time. Our formula, not a bad idea mathematically to put that down as a mathematical reason for your answer there. Right, lots of practice here. I think a half a dozen. You could do those quite nicely, easily. Here are the answers. Check it. Try not to look across before you've done yours. All right, we're building up. Can you get a sense of empowerment here on the Cartesian plane in coordinate geometry land? Hey, I think you could do a lot now with shapes on that plane. Okay, come down now and let's have a look at another way of looking at the midpoint. And this is rather interesting, and this links up important work with slopes. So let's have a look. What is B this time? If M is a midpoint, so we're given the midpoint, there's the midpoint, same problem, and A is one of the ends. Can you suss it out using equal steps? What do they mean? Let's have a look. If we know going from A to M is the middle point, how far have we gone? Well, in X land, let's take them away. It's 4, take 1. We've moved across 3 in X land. And then how far down have we moved? Moved from 3 down to -2. Can you see -2 take 3? The Y step is -5. Well, if this is the midpoint, if M's a midpoint, then we should do it again, shouldn't we? Exactly the same movement. So let's do the same movement. We'll have to add 3, that'll give us 7, and then take 5, -2 take 5 would be -7. They've done their working out over here. Okay, get the idea. It's to duplicate that crucial property of a straight line. What is the crucial property of a straight line? What makes a line straight? Do you remember from the previous presentation? What is that crucial property that why is a line straight? It's the slope, isn't it? Or the gradient. of the line. Same thing, different words. So that's what keeps the line straight. This stepping constantly between points keeps it straight. Y step over X step. And we're using that now in a tricky way to backtrack to find this endpoint using a step procedure. Do you want to go back and just check your answers from question 3 and see if you can do it with that slope method? All right, we're coming to the end. Just to come down, got a few puzzle problems now for you. Not going to tell you very much about this at all. This is a backtracking one. You can, if you get lost with this work, of course. The advantage of coordinate geometry is you could always plot the points and have a look. AB is the diameter of a circle, centre C. If A is at B, find the coordinates of C. Or do you know some geometry? What's the relationship of the centre of a circle in there to the diameter? That might have something to do with it there. So you think about, how can I use my stuff here now to do that? Oh, well, somewhere in here is C. Think about that one. And here's another one, of course. If PQ is the diameter and you've got the centre, there might be a bit of a backtracking one there. Diagonals of a parallelogram bisect each other at X. Okay, bisect, oh, that'll have something to do with midpoints. Look at it there. 2 equal points there, 2 equal line segments and both diagonals, because the diagonals bisect each other. Think you can use some midpoints there, and then a triangle one at the end. So you might think about that, and there are the answers over here. Okay, so if you want to get into more advanced stuff now, have a go at question 5 through 9. Well, I hope you're happy with the way your skills are building up on the Cartesian plane. It's got great potential for your geometry of the future. So at the moment, though, it's cheers from me. Catch you later on.